Okay, you guys, the time you have been waiting for has finally arrived. It is all story problems all day long. Section 7 is applications. So I've kind of split it into different types of story problems, and I'm going to go through each type, give you kind of a formula if there is one, show you an example or two of each type, but also realize that story problems are different every time. So, although the basics of what I'm going to show you will hold true for every problem, each one is going to have its own um, twist, let's say. So, we'll start with simple interest. And this is just interest like when you borrow money and then you have to pay back um, what you borrow, plus you're going to pay interest on what you borrowed from the bank or another person. But it also has to do with if you make an investment or you have a savings account where they're going to pay you back some money for letting them borrow your money. So the formula we're using is I, which stands for the interest earned, equals P, which is the principal, not like, principal, not principles. Principal, it's spelled like principal, like the principal of the high school, but that's not what it means. It means the starting amount. So either how much you initially borrow or how much you initially deposit. And then R is the interest rate. And when you use interest rates in problems, it's always going to be as a decimal. And then T is time. So we have I equals P times R times T. And this is the formula we're going to be using for our interest story problems. Here we have an example. Betsy is a retiree. She needs $6,000 a year in extra income. She has $50,000 to invest, and she can invest in two different types of accounts. There's a B rated bond that pays 15% a year, or a certificate of deposit that pays 7% per year. How much money should Betsy invest in each to realize or earn? That word realize means earn exactly $6,000 in interest per year. So let's see what Betsy's got going on. She needs to earn $6,000 in interest. So that's going to be I in our formula, interest. So we've got 6,000 interest total. And she's going to be earning interest from two different sources. She is going to be earning interest on her B bonds. And she's also going to be earning interest from her CD. So this little story problem has kind of two of these formulas in them. So for our interest in our B bond, we're going to have principal times rate times time. And our interest from our CD, we're going to have principal times rate times time. So we've got to figure out what's going on with everything. So we're going to start with our formula. 6,000 is going to be our interest. And then for the B bond, she has a, oh, that's really loud, huh? Hang on, I gotta get a pen. Okay. She has $50,000 to invest, And B bonds pay 15% per year, and then CDs pay 7% per year. And for our time, it doesn't specify, but it says per year. So this is going to be, per year is going to be our time for each one. So our time is always going to be 1. So we can fill that in on both of them. And we can fill in our interest rate. CDs are 7%. So to change 7% into a decimal, remember we're going to take our decimal point, move it 2 to the left. So 0.07. So 0.07 for our rate. And then B-rated bonds, move the decimal twice, 0.15. And then we just need our principal. All it tells us is she has $50,000 total. So we've got to figure out what that amount is going to be. So we need to figure out the amount that she's going to have in B bonds and the amount she's going to have in CDs. So let's kind of take a little side trip and we'll figure that out. So I know she has $50,000 total. Where can I fit this? How about kind of over in the margin? She has $50,000 total. And she's going to put some of that in B bonds, some of that in CDs. So if I figure that the amount she has in bonds plus the amount she has in CDs is 50,000, then I can use like the letter B for how much she invests in B bonds. So let's say that B equals amount invested in B bonds. Make sure that you define your variables at some point. It doesn't have to necessarily be at the beginning of your problem, but once you figure out what your variable is going to represent, define it so that when you're done, you know what your answer means. So we're going to use B to represent how much she invests in B bonds. Then how are we going to know how much she invests in CDs? We don't want to use two variables necessarily, so we can just use this equation. If we subtract B from both sides, then the amount she has in CDs will be 50,000 minus B. So let's use that. And then be really careful with your equations, because I need to take this amount, 50,000 minus B is P. So I need to make sure that both of those get multiplied by that 0.07. So to finish off my formula, I'm going to have B times 0.15 times 1, so 0.15 B. And then I add to that, because I have that addy thing, the addition sign. So 0.15 B plus, I'm going to move my 0.07 out in front because I feel more comfortable with it there. And commutative property of multiplication says that I can rearrange the order of multiplying. So this is now the formula or the equation that I need to solve to figure out how much money she's going to invest in B bonds, since that's what my variable is representing. So from here, it's just really, regular math that we've been doing since a long time. So we will use the distributive property to distribute that 0.07 in. So now we have 6,000 equals 0.15B plus whatever 0.07 times 50,000 is 3,500 minus 0.07B. Then if we combine these like terms at the same time, hopefully you're okay with this, at the same time I'm going to subtract that 3,500 over to the other side. So 6,000 minus that gives me 2,500 equals 0.15 minus 0.07, 0.08B. And then keep on solving, divide both sides by 0.08. So 2,500 5 by 0.08. So B is going to equal 31250. So that tells me that she is going to invest, or she should invest, $31,250 in B bonds. And then we've got to figure out how much in CDs. And we have that kind of right over here. So her amount she invests in CDs would be 50,000 minus 31250. So 50,000 minus 31,250 would be 18,750. So that's how much she'll have in CDs. So remember to put units when you finish a story problem. In this case, the units were dollars, and be specific about it. So I've that's not really a complete sentence, but it's sentence-ish. It at least has some context within the story problem so that whoever reads it can know what your answers meant. Okay, well, actually, we're going to come back and do some more on this story problem later. But for now, we will move on to working together. Now, when we were in Algebra 2, at least if you were in Algebra 2 with me or in any Algebra 2 class at my school, working together, we would use this formula: 1 over me plus 1 over you equals 1 over us. That formula still stands, but there's going to be a little bit more to it than that when we have more complicated problems. So we'll keep this formula in mind. 1 over the amount of time it takes me to do a job by myself plus 1 over the amount of time it takes you to do a job by yourself equals 1 over the amount of time it would take us if we were working together. So this simple story problem, we can use that formula. Patrice by himself can paint 4 rooms in 10 hours. If he hires April to help, they can do the same job together in 6 hours. If he lets April work alone, how long will it take her to paint 4 rooms? So in this case, it's Patrice, April together. So based on our formula, we would have 1 over Patrice's time plus 1 over April's time equals 1 over the time it takes together. In the reading, we find that it takes Patrice by himself 10 hours. So this is 10. Together, they can do the same job in 6 hours. So that's 6. And then we want to know how long will it take April. So this is what we don't know, is April's time. So whatever variable you want to use, we need to define that. So it would be the amount of time. Uh-oh, I sat still too long. Hang on. There we go. The lights turn off if you don't move around. The amount of time it takes April, technically, to paint 4 rooms by herself. Now, the 4 in this problem, we are not using that in any of our computations. It's a distracting number. It's just there, but it's not important to our computations. I mean, that happens all the time in the real world. So if we use X or if we use A, whatever you want to use for your variable, you can choose that yourself. So as we go through our formula, we will go 1 over Patrice's time plus 1 over April's time equals 1 over their time together. And then we just have this equation to solve, and it looks a little bit more complicated than some other equations we've worked, but we have a strategy for that. Remember that we want to clear the fractions. This is a strategy we'll use a lot. And to clear the fractions, we're going to multiply by the LCD over 1 times each of the terms in that equation. Each term. Okay. So our denominators are 10, x, and 6. That LCD is going to be 30x. So we will multiply by 30x over 1 times 30x over 1 times 30x over 1. And then we simplify from there. 30x times 1 over 10 would be 30x over 10, which is going to simplify to 3x. And then 30x over 1 times 1 over x would be 30x over x, which will simplify to 30, equals 1 over 6 times 30x over 1 would be 30x over 6, which will simplify to 5x. And then we just solve this little equation that looks pretty straightforward. So 30 equals 2x, which leaves us with 15 equals x. Now we already know what x represents. X represents the amount of time it takes April to paint 4 rooms by herself. So then we are done with our problem except for stating the answer. It would take April 15 hours to paint 4 rooms by herself. The next working together problem we're going to do is a little bit more complicated. So we're going to use this formula here, which is actually the same as this formula. If we put all the information in here and simplify it, it comes out the same. But this one, I don't know, it's a little bit more broadly applicable. So what we're going to do is figure out the fraction of a job that could be completed in 1 hour. So thinking about that, when Patrice is working by himself, it takes him 10 hours to complete a job. So the fraction of the job he could do in 1 hour would be 1/10. And that's in our formula right there. And then times the time worked. So in our problem up here, we just figured it was 1 hour each time. So that's why it's the same, but this is going to work out better for us when we have more complicated problems. So we're going to do fraction of a job that can be completed in 1 hour times the time worked plus the fraction of the job that can be completed in 1 hour times the time worked is going to equal 1 total job done. So this formula up here is assuming that both people are working the same amount of time as each other. This one is not making that assumption. So in this more complicated formula, I could work for 6 hours and someone else could work for 2 hours, and we could still figure out how long it would take us to get that job done. So Bob can mow in 5 hours. Joe can mow in 2 hours. What time should Joe start helping if Bob starts at noon and they need to finish at 3? So we got Bob Bob can mow in 5 hours, and Bob starts at noon, and they need to finish at 3. So since Bob can mow in 5 hours, the fraction of a job he can complete in 1 hour is going to be 1/5 because it would take him 5 hours to finish. And then the amount of time that Bob is going to work, he's going to start at noon, finish at 3. So he is going to work 3 hours. So we have 1/5 of a job times 3 hours. Then we've got Joe. Joe can mow in 2 hours. So in 1 hour, Joe can finish half of a job because it takes him 2 hours, so he can do half of the job in 1 hour. We don't know how long Joe is going to mow, so that's going to be our variable. Actually, they want to know what time he should start, but that doesn't fit in the narrative of this formula, so we're going to say x equals how long Joe mows. So we're going to use x. And then we know that it's one job total, and that's always consistent. So this formula always equals one total job done. So let's simplify this formula up a little bit. We've got Bob 1/5 times 3. So that will be like 1/5 times 3/1. So 3/5 plus Joe 1/2 times x/1. X/2 equals 1. And again, we've got that fraction situation. So we want to clear those fractions. Just this time, the LCD is going to be 10. So times 10/1 times 10/1 times 10/1. So that's going to give us 30/5, which would be 6, plus 10x/2, which would be 5x, equals 10. And now it's just a really simple equation to solve. So we get 5x equals 4. So x equals 4/5. Now in terms of time, that's going to be in hours. So we know that, I'm going to move up to here. Joe is going to mow for 4/5 of an hour. So let's figure out how many minutes that's going to be. We'll take our 4/5 of an hour times 60 minutes in 1 hour. And that's going to give us 240 divided by 5. 240 divided by 5 is 48 minutes. So Joe needs to mow for 48 minutes. Remember that they need to finish at 3 o'clock. So if we take our 3 o'clock and we subtract 48 minutes, that's going to tell us Joe's starting time. So we're going to have to do some time math. Time math, I think, is harder than regular math because it's not based on tens, it's based on 60s. So I'm going to have to borrow an hour to my minutes. 1 hour is 60 minutes. So that's going to be 2 and then 60 minus 48, which I think is 12. But I'd better double check. Yes, 2:12. So Joe should start at 2:12 p.m. Okay, we are going to put a pin in it at this point, and I will come back and do more videos over the other types of story problems. So I will see you next time.